it to see if it makes sense once we add this into it. So we're going to say operations with functions Okay, so for the first example, we're going to say that we have two functions. We have f of x is x squared plus 2x plus 1. Sorry, minus 1, x squared plus 2x minus 1. G of x is x minus 5. And if we had to find f of x plus g of x, this is a function operation because I have two different functions. I am adding them together, which is an operation. So if I'm adding them together, it's pretty easy. I'm literally just going to write f of x, x squared plus 2x minus 1, plus g of x, which is x minus 5. Do I really need the parentheses around these? No. So I've got x squared plus 2x minus 1 plus x minus 5. And at this point, what am I needing to do? Just combine like terms and then I'll be done. So I've got x squared. What else do I have? Plus 3x minus 6. Okay. Okay, what if I was doing the exact same problem, but they said find f of negative 6x plus g of negative 6x? You're close. With the x. Negative 6 with the x. So you'd be doing the same problem, but instead of writing an x and an x and an x, you would be taking these x's out, and you'd be replacing them with negative 6x. So there's two different ways of doing this problem. You can start the original problem by writing f of x and g of x and replacing the negative 6x in the beginning of the problem. Or you can take f of x and g of x and add them together first, and then take the result and plug negative 6x in at the very end. Two different ways of doing it. They're both valid. Okay, so we're actually going to write both of the ways so that we can see that they both work out, since these are our notes. We want to make sure that our notes make good sense. So let's go ahead and let's do this version first, where we're plugging the negative 6x in and then seeing what the final answer is. So I'm going to take f of x, I'm going to plug negative 6 in for each x. So I like to do this with colors so I can see exactly where I'm plugging it in. If you don't have colors, that's okay. It's not a huge deal. So I'm going to be plugging negative 6x into 3 different places. So for f of x, I'm going to have f of x plus g of x, two different things. So I'm going to have negative 6x squared plus 2 times negative 6x minus 1. So there's f of x. Negative 6x squared plus 2 times negative 6x minus 1. Is everyone okay with that? Okay. And then for the other one, I have negative 6x minus 5. So I took out the blue x's and I just replaced them with negative 6x. We good so far? Okay. So now for this part, to simplify this part, I have to do negative 6x squared. So that's negative 6x times itself. Negative 6x times negative 6x is 36, just 36x, x squared, okay. 2 times negative 6x, negative 12x, okay, and then a minus 1 on the end. Okay, and then over here, so we've got plus, and then we've just got negative 6x minus 5. All right, so now if I combine like terms, so this parentheses was just to multiply these two. These parentheses out here were just to say that this whole thing was f of x. So this whole thing was f of x. I don't really need them anymore. Yeah. Okay. And then over here, this whole thing was g of x. These parentheses were just so that I knew what I was plugging in for this x right here. But since nothing is being multiplied by it, I don't really need those parentheses. So at this point, I'm ready to combine like terms. So what do I have? Okay, so there's my final answer if I do it that way. If I do it the other way, then I would have started off with f of x, and we already know what this one is because we already did the work for this. I would have done f of x plus g of x if I did it the other way. And then I would have combined like terms and gotten x squared plus 3x minus 6 because I've already done that work. I did that in the previous example. I added them together. And then at this point, after I add them together, then I would go back and I would plug in the negative 6x. And I would have two places to plug it in. I'm going to plug it in here and plug it in here. So I would have negative 6x squared plus 3 times negative 6x minus 6. And so what does this part give me? 36x squared. What does this give me? Negative 18x and then minus 6. So if you guys can see, it doesn't matter which way I do it. It's going to give me the same answer either way. Is there one method you guys think is a little bit easier than the other? We like this method better? Yeah. So this method is plug in negative 6, then add. This one is add, then plug in negative 6x. So they both give you the right answer. It just depends on what order you prefer. And we're thinking maybe it's a little bit easier to add them together first and then plug in the negative 6x. Okay, let's try another one. So this one says f of x equals x squared minus 81. G of x is x plus 9. Okay. So the first thing that we're going to do is we're going to find f of x plus g of x. So what do we need to do? Combine, so we're going to write it down, we're going to combine like terms. So f of x is x squared minus 81. G of x is x plus 9. So what do I have? plus x minus 72. Okay. And then should I like try to factor that or something? No. It does factor. This is factorable, but I don't have to like go on and try to do something else because the instructions never asked me to. So just because I recognize that maybe something else could be done with the problem doesn't mean I should do that. Not unless they ask me to. Okay, so that problem's done. We finished that one. All right, for the next one, we're going to find 4f plus 7g of negative 3. Whew. Mm-hmm. Mm-hmm. So just like before, there's two different ways we can do this problem. This is saying this is 4f of x's, this is 7g of x's, and that instead of having an x inside of the equation, we're going to have a negative 3 inside of the equation. So the two ways that we could do the problem is we could do the problem and plug in the negative 3's to start with. So we could take the f of x function, we could plug the negative 3 in. So take 4 of these with negative 3 plugged in, take 7 of these with negative 3 plugged in, and then add them together. That's one option. The other option is that we could take 4 of f of x's with the x's, take 7 g's with the x's, add them together in terms of all the x's, and then plug a negative 3 in when we're done. Those are the two options that we could have. So we're going to go ahead and do it both ways because I just want you guys to see with the first couple of options, like how both ways work. And then after that, let you guys kind of choose. I know I can do it both ways, but based on the problems that we did in our notes, this is my preferred method. Does that make sense? And then after that, you can kind of make a choice about which way you like to do. So we're going to start off by figuring out what 4 times f of 3 is, okay? Or negative 3, okay? So what I like to do when I have to do something like this, 4 times f of negative 3 is, I like to ignore the 4 and just figure out what's going to happen when I plug in negative 3. So let's do negative 3 first. Negative 3 squared minus 81. Negative 3 squared minus 81. So can we figure out what that is? We've got 9 minus 81. What is that? Negative 72. Okay. So that's negative 72. And then we've got 4 multiplied by that, right? 4 multiplied by that. So 4 multiplied by negative 72 is negative 288. We got somebody else agreeing with that? Yeah? Okay. And then let's figure out the other one. We've got 7g of negative 3, so let's ignore the 7 to start with. What happens when you plug in negative 3 plus 9? Negative 3 plus 9, what do we get? 6, okay. And then we'll stick the 7 in the front. That's 42. Okay. So at this point, we've done all the numbers. We're not really dealing with x's, right? We're just plugging, we're kind of dealing with x's. We're plugging the negative 3 in for the x and just getting the numbers. So now we can do 4f of negative 3 plus 7g of negative 3, and we're going to get negative 288 plus 42. Negative 246, there's our answer. Okay. We all comfortable with that? That makes sense? Okay. So the other method is to figure out what 4f is, figure out what 7g is, and then at the very end plug in the negative 3, right? So let's go ahead and do this part. So I'm not going to write the instructions again. So if f of x is x squared minus 81, then if we did 4 times x squared minus 81, what are we going to do with that 4? We're going to distribute it, okay. So what do I end up getting? $324, okay. And if we distribute the 7, what do we get? Okay. And at this point, let's go ahead and combine our like terms. 4x squared plus 7x I'm getting two different answers. 279, 261, 279, negative 324 and 63. 261. Okay, so at this point, what are we doing? We did 4 times f of x, 7 times g of x. Now we got to plug in the negative 3. So negative 3 squared plus 7 times negative 3 minus 261. And what are you guys getting for that? Anybody? What are we getting? What should we be getting? We should be getting negative 246. Okay, did you guys get negative 246? Negative 246? Yep, perfect. So another way of doing it, which way do we prefer? The one on the left? A little bit easier. So with this one, it's easier to plug the number in. Then add. This one was add. Then plug number in. So there's a little bit of strategy involved when you do these, when you're evaluating at some values. Sometimes it's nicer to, maybe when you're working with x's, to add first and then plug the value in. But if you're working with numbers, it can be a little bit easier to plug the number in and then do the operation. I think that kind of makes sense because here you're adding when things are more simple and then you're plugging something in once you've simplified it a little bit. Here, numbers are easiest. So you can plug the number in while things are kind of more complicated and separate. And then since numbers are easier, then you can work with things and put them together when you've simplified it and used a number. So it makes intuitive sense once you kind of think it through. Okay, let's do a couple more, but now we're moving on from addition. We're going to do some subtraction and multiplication. Okay, so this problem, we have f of x is, we're going back to x squared plus 2x minus 1. And g of x is going to be x minus 5 again. And we're going to find f of x minus g of x. So what should I write? So x squared plus 2x minus 1 minus x minus 5. Do the parentheses matter? You have to distribute the negative. So the first set of parentheses don't really matter, but the second set of parentheses definitely do. So the first ones I'm just going to copy down. the second one I had to distribute the negative. So what do I have now? Negative x plus 5. And so what does that give me? Okay, so if I subtract f and g, I get x squared plus x plus 4. What if I do 2f minus 3g of 5? Now this time we're not going to do two methods, we'll just do one. How would you guys like to find the answer for this? The first way that we did it? So what was the first way we did it? What was easier? Plug in 5, and then, so we're going to do 2f of 5. So we're going to plug in the 5. We're going to ignore the 2 to start with. We're going to plug in the 5. So we're going to do 5 squared plus 2 times 5 minus 1. So what is this? 25 plus 10 minus 1. So 25, 35, 34. Okay, so 34, and the number in front was a 2. So we're going to go back and put a 2 in front, go back and put a 2 in front. So what does that give us? 68. Okay, this is 68. And then we're going to do 3 times f of 5. So I'm going to ignore the 3 to start with. Oh, g, not f, g. Okay. So plug in 5 for g. So 5 minus 5 is 0. Put in a 3 in the front. Still 0. So we're going to do 68 minus 0 is 68. Okay. That method is good. We like that method. So let's remember that one was a good one for us. That worked. Okay. Let's do another subtraction problem. So here we're going to go back to the previous f of x and g of x. I didn't realize my examples that I stole online did that. Sorry, we're going to have to write them more than once. So this is going to be x plus 9. Okay, so here we're going to find f minus g of x. This is still subtraction. It's just another notation. So this still means f of x minus g of x. It's just a different notation. It still means f of x minus g of x. It's just a different notation. All right, so what should I be writing? So x squared minus 81. Okay. So Carly was already telling me what I'm going to have when I distribute the negative. So minus x minus 9. And so when I combine like terms, what do I get? Minus 90. Okay. How have your brains been doing? Good. Are we remembering any of this from Math 3? Does any of this feel familiar? Yes? Okay. So today isn't so much about new stuff as it is being less rusty and then maybe pushing your brain a little bit further than Math 3 did. So taking what you've already learned, but then maybe giving you problems that are a little bit more difficult. Okay, so now we're going to find f minus g of 2x. F minus g of 2x. So what method would you like to use? Would you like to do f of 2x minus g of 2x, so plug in the 2x first and then subtract them? Or would you like to subtract them first and then plug in the 2x? Subtract first and then plug in the 2x? Okay, so if we subtract first and then plug in the 2x, that's kind of nice because we already know what it is when you subtract first. So we can say, let's take the x squared minus x minus 90, because that's what we got when we subtracted them first. Okay, and now I'm going to take my x's, I've got x's in two places, and I'm going to go ahead and plug in 2x for my x's. So I'm going to have 2x squared minus 2x minus 90. I know that the parentheses are unnecessary here, but I like to put them just in case. I don't know, sometimes the parentheses really are necessary. Okay, so over here, 2x squared, 2x times itself, what does that give you? 4x squared, okay. Here they're unnecessary, minus 90. Okay, there we go, done. Okay, we're going to go back to the first. I'm going to switch up these problems a little bit. Minus 3x plus 7, x plus 8. Okay, here's the one we're going to do. X squared minus 3x plus 7, x plus 8. And we're going to find f times g of x. So f times g of x is another way of saying f of x times g of x. That's all it is. F of x times g of x. That's another way of saying that. And here we have 3 terms multiplied by 2 terms. So there's the FOIL method. I do not like to use the FOIL method, like where you put them in parentheses next to each other and kind of distribute. I don't like using that method when I have this many terms. I always use a box when I have this many terms. Are you guys okay with me using a box for this, or would you rather use the FOIL method? Okay. So if we have 3 terms multiplied by 2 terms, I usually make my boxes longer versus taller. So I would make it 2 terms on one side and 3 terms on the other side. But if you want to make your box taller, then that's fine. So I'm going to make it 3 terms on one side, 2 terms on the other side. The nice thing about the box is that it organizes your terms for you. So it's easier to combine like terms when you're done. So I'm doing f of x across the top and g of x across the side. And I'm just making sure that if they're positive, that they're positive when I write them, and that if they're negative, then I'm putting the negative sign in there. And then I'm kind of treating this like a multiplication table. So x squared times x is x to the third. Negative 3x times x is negative 3x squared. 7 times x is 7x. X squared times 8, 8x squared. Negative 3x times 8, negative 24x. And then 7 times 8, 56. Okay. So the nice thing about the box is it always puts the like terms on the diagonals for you. It'll always do that. So x to the third comes first. And then we have 8x squared and negative 3x squared. Okay, 5x squared. And then we have negative 24x and positive 7x. Negative 17x. And then we got 56. Okay, there we go. Okay, for the next one, we're going to do f times g of x squared. F times g of x squared. So if they wanted us to find f times g of x squared, what should we do? Plug in x squared for all of the x's. So we already did the f times g part. Now we have to take the x's and plug in an x squared for all of the x's. So I'm going to say x squared to the third plus 5 x squared to the second minus 17 x squared. That one didn't really need a parenthesis, but I put it anyway, plus 56. How does it work when you have an exponent to an exponent? Say it again. Does it add? So think about, so we've got two options. We could have like x squared times x to the third, x squared to the third. So one of these adds and one of these multiplies. The first one adds. This would be x to the fifth. This would be x to the sixth. Okay, so we got to multiply these. This is x to the sixth plus 5 x to the fourth minus 17x squared plus 56. Okay? Okay, we're going to do one last problem. Let's do f of x is x squared minus 4. G of x is negative x plus 1. We're going to find f of x times g of x. So what do I need to do? Yeah, we're going to write them next to each other. We're going to make sure we put them in parentheses. And we're going to FOIL them, or you can use a box. If you prefer a box, you can use a box. Whenever I have two terms by two terms, I usually FOIL them. So x squared times negative x. Negative x to the third. X squared times 1 is just x squared. Negative 4 times negative x plus 4x. Negative 4 times 1. Negative 4. All the terms are different. They happen to be in the correct order, so that's my answer. Okay. All right, so do we understand the notation? If we have to plug something in, do we know how to plug it in? Yes, okay. So I've got an assignment for you.